AI is exploding and making the entire world go crazy. I am going to show you 5 secret work that AI researchers at Meta have been doing for quite a while that has recently been published. Even if you have no technical background, but you are still interested in learning how the heck AI can affect you and what's the current state of AI, stay tuned until the end of the video because we will explore 5 mind-boggling video-related AI features that Meta is working on and that it might end up adding it to the social networks like Facebook, Instagram, and even WhatsApp. Let's check these 5 unbelievable achievements that Meta AI team has achieved in recent months, and these shocking AI advancements are making rounds all over the industry.
The biggest narrative this year, artificial intelligence.
So here is a simple question for you that you need to ask yourself before watching this video. How much an AI model understands a picture or a video? So what I'm trying to say is, if you are given a random video of yourself and your wife making a smoothie in a kitchen while your friend is watching the TV in the background, how much of this video can AI understand? Can AI detect that there are 3 people in this video? Can AI understand that 2 people are working on the same task while the other is working on a different task? Can AI explain that 2 people are making a smoothie or a shake while the other person is watching TV? Can AI detect that these 3 people are talking to each other in the video? Has your mind already blown? Let's unpack each of these 5 jaw-dropping advancements in AI that Meta has already achieved. So the first one is Egocentric Video Task Translation. Let's break this down. So egocentric meaning when you keep yourself as the reference point. The idea here is if we give AI a video that is from the first person, meaning a camera on your wearable glass or even a camera that you may be holding in your hand and moving around, can the AI detect a person looking back at the camera or talking back to the camera? Can the AI detect multiple things happening in front of it all at the same time? In previous AI advancements, different video understanding AI models have been created that detected one and only one object or action at a time. For detecting multiple objects and multiple actions, a single AI system had to rely on multiple AI models all working at the same time to detect these different things. For example, AI models in an autonomous car. In it, there is a model detecting human around the car. There is a model detecting different types of objects around the car, so on and so forth. You get the idea. These were multiple models all working together. The biggest revolution of this new egocentric video task translation is a single AI model is able to detect all of it all at once, and it's performing better than all previous benchmarks. For example, in a single video from a wearable camera, this AI genius can detect hand object manipulation, navigation in the space, or human-to-human interactions. Remind you, we are talking about a real video here, meaning all these actions are unfolding continuously. This near revolution in AI has created a single unified model that detects all of it, the action, the person, the conversation, and the surroundings, all of it at once with more accuracy than all previous benchmarks. So you may ask, how in the world did they achieve this? So this video action translation algorithm called EgoT2, which takes a collection of models optimized on separate tasks and learns to translate their outputs for improved performance on any or all of them at once through a unified AI magic model that can detect anything and everything in this video. I'll link their video and the paper in the description below. The second one is LLM. I hope I'm pronouncing it correctly. Also known as Language Augmented Video Language Pre-training. Let's break this one down. So before we get into this, a reminder on LLM. LLM stands for Large Language Model. It's the same technology on which ChatGPT is built on. In this new revolutionary AI model, Meta repurposes existing LLMs to be conditioned on visual inputs, and the researchers fine-tune them to create automatic video narrations. What in the world does this mean? Think of it like this. You'll take any video of your choice where an action has been performed, feed it into this magic AI model, and it will not only detect what's happening in the video, it will generate exact narrations of what happened in the entire video. This video to text embedding learned with these additional auto-generated narrations outperforms all the previous state-of-the-art on multiple first-person and third-person video tasks of detecting as well as producing narrations what is happening in the video. So before I tell you the most epic success of this AI model, I want to tell you about something called Ego4D. Ego4D refers to a dataset specifically designed for egocentric video understanding tasks. It is a collection of diverse egocentric videos that capture human-object interactions and human-to-human interactions from a first-person perspective. LLM, this crazy magical AI model, was trained with only half the narrations from the Ego4D dataset, and it outperformed all AI baseline models trained on the full Ego4D dataset. This is simply awesome. So up next, I want to talk about GeneCIS, a revolutionary idea that can detect if two images are similar in the craziest of ways possible. Let's jump right into this one. This research is done by Meta in collaboration with Oxford University. The argument here is that there are many notions of similarity that humans understand, but AI machines don't. And in this revolutionary research, they have shown how an AI model should do the same and be able to adapt dynamically. Let's break this down. For example, an AI model whose job is to detect object categories may only detect that object category and nothing else. For example, an AI model that is built to detect a cat or a dog will only be able to detect a cat or a dog and nothing else. And even for a picture of a cat, a simple AI model is not able to detect the color of the cat, where the cat is standing, if the cat is eating anything, if it's a day scene or a night scene, and many other specific elements in the scene. That is the problem with existing AI models. Now, to understand this extremely clearly, let's assume you have a single picture called the reference picture that you are going to feed into this AI model. On the other hand, you also have a huge collection of pictures as well. You want your AI model to find every single picture that matches not just your reference picture, but also the similarity condition that you will feed into the model. This similarity condition is the biggest twist. Let's take an example. Let's take this picture as our reference image. I'll feed this reference image into the AI model with 3 different conditions one by one. In the first condition, I'm asking it to find another image with the same car. In the second condition, we are asking it to find another image with the same bridge. And in the third condition, I'm asking it to find another image with a black car. The results, as you can see it, are simply mind-boggling. So the next one we are going to discuss is going to make you go even more crazy. But a quick pause, if you haven't subscribed to this little baby channel, please consider doing so. My mission is to help common people understand what AI is and how it's going to revolutionize our world. Every single video is an attempt to unveil the secrets behind this AI magic for common people like you and me to understand. So the first one I want to talk to you about is HierVL or HierVL, whatever. There are tons of simple image recognition models that can handle and detect what is in the image, and we have talked about them in this video earlier. Also, there are existing video understanding models that do an okay job of figuring out what is happening at short intervals in the video. For example, looking at a 2-second video, a model can tell that the person is trying to fetch water in the pot. Then the AI model can look at the next 2 seconds, analyze it, and tell you that the person is cutting the onion with a knife. But here is the problem. These old AI video understanding models are only good at detecting these smaller quick scenes made up of few seconds. So this new revolutionary research from Meta AI, done in collaboration with the University of Texas Austin, can do something that looks truly magical to me. It can look at an entire video, look at the small clips and its interpretation from the model, and can come up with a legit summary for the entire video. Meaning, looking at this video, the magic AI model can tell that the person is trying to make a salad dressing with some oil and sauce, which is extremely damn accurate. So one huge effect of this AI advancement is that it has beaten all previous AI models on 3 huge datasets used to understand video. The first is Epic Kitchen 100, which is a huge dataset capturing all daily activities in the kitchen over multiple days. Another Ego dataset by Shreds Ego, a more than 7,000 video of daily indoor activities from both third and first person. And the biggest of it all, How to 100M, is an extremely large 136 million video clips with captions sourced from 1.2 million YouTube videos. It covers 23,000 activities from domains such as cooking, handcrafting, personal care, gardening, or fitness. So this magical AI model has performed better than all existing AI models on all of these tasks. All I'm thinking is, what should I say next in this video? Will these AI models tell me? Can these AI models detect what I'm going to say next? And can these AI models predict if you will do what I asked you to do right now? I'm not sure about any of this, but all I wanted to say is smash that like button, subscribe because it's free, and share this video with your friends who is maybe excited about AI or too afraid of it. And last but not the least, Meta has released PACO, a large-scale dataset providing object mask, part mask, object level attributes, and part level attributes. You can build your own machine learning models using the images in this dataset for 3 levels of queries. In level 1 query, in which you can ask the model about one object part only, for example, a red cup, meaning to tell if the image has a red cup or not, or a red cup with a red handle to detect if there is a cup in the image that has a red handle. Then there are L2 level queries in which you can query for 2 objects or part attributes, for example, red floral cup or red cup with a metal handle. Lastly, you can also do L3 level queries in which you can ask for 3 dimensions, 3 objects, or 3 attributes. For example, red ceramic cup with blue handle. This data set opens up some extraordinary opportunities for you to go and build your amazing applications for image detection. Alright friends, that's all that I had for today. Until next time.